In this lesson we're going to show you how to plot and graph in 3D. What that means is we're going to actually start adding in a new variable. Instead of just having x and y in our equations, now we got a z. Instead of just having an x and y on our coordinate plane, we're also going to have a z. So this is what we're used to. We're used to the normal coordinate plane with x and y. And all equations usually have an x and a y and then are equal to some kind of number. Or if it's in slope-intercept form, then it goes like this. But the whole point is that there is two variables in every single equation. What if we had three? What if we had to do x, y, and z? Here's what it would look like. We've now kind of imagine that the old way of graphing was a flat piece of paper and you laid it flat down onto the table. And then you pulled up another axis, with a piece of yarn or string or something, straight up in the air, away from the paper. That's our new axis, the z-axis. Now we still have positive and negative numbers, so let's go over that and talk about where we find them. If you go forward and backwards, that's the x-axis. Forward is going to be positive x's. Backwards is going to be negative x's. Y is now going left and right. To the right is still positive, so these are positive y's, and to the left is negative y's. We also still go up and down. Up is positive, so these are positive z's, and going down is negative z's. So now we know where to find these numbers, count them out, plot points, and I'll show you how to do that. The first method of plotting a point is called I'm going to call is the box method. We're going to draw a 3D box. So let's look at what a point looks like with three variables. The first is x, just like it was before. The second one is y, so the 2 is y. And the last one is z. X, y, and z. So now let's go ahead and start plotting these. First, let's find positive on the x-axis. That's forward. Now go to positive 2 on the y-axis. That's to the right. And then positive 3 on the z-axis. That is up. These are not the actual point. This is not point A. None of these are point A. What these are, they are kind of like helper points. They're going to help us draw a box. I'm going to start drawing this box by drawing lines. Hold on a second. I'm going to use my line tool. By drawing lines to the origin. Like there, there, and there. These are the beginning of our box. Now let's draw the bottom of the box. Remember it's in 3D, so you want to kind of make it slanty. I could probably draw that one a little bit better. There you go. Now let's draw the back. That's easy. That's just going to look like a rectangle. Now, to draw the other ones, getting a little bit harder. So we're going to have to draw this up. Kind of draw the other side diagonal. That looks about right. And this one is going to come straight up. And there, and there. And you've gotten yourself a 3D box. Yours will probably be as sloppy as mine. The point is draw this 3D box. But where on all these spots is the actual point? Well, let me point it out to you. It's right here. I know it's here because this is the spot where all the lines are coming up to, where the red is pointing to, where the blue is pointing to, where the green is pointing to. This is where they all are going to. But not ever can you draw a line going back to any of them. It doesn't go back to blue, it doesn't go back to red, it doesn't go back to green. If I had accidentally put the point down here, then it does go back to green, it does go back to red. So technically we're not using blue. If I accidentally put it over here, this one would go back to blue and go back to red, and that means I'm not using green. So only in this spot is point A. So this is what we call the 3D box method. Now I'm going to show you another method. So this one kind of goes like this. First, start out by finding our -2 for the x, that's going back. -2 for the x right here. And then we're going to go to +1 for y, right here. And what we're going to do now is we're going to draw this, this kind of like a parallelogram is the best way to describe it. So I'm going to draw a line going to the origin, just like before, and now make a parallelogram. So we'll call this the parallelogram method. Alright, so this connects x and y. But what about the z? The z is -4. That would go down to -4. Now here's the wrong thing to do. Don't go down all the way to -4 right here. If I said, well, -4 is right here, then I'm supposed to draw a line that goes all the way down to it. This is incorrect. We don't want to do that. Instead, what you want to do is find how long it is to go down to -4 on the axis. And then you would slide this line to where the x and the y meet. Where this line points down to, that is our actual point B. There you go, point B. So that's the parallelogram method and the box method. You're going to have to choose the one that works the best for you. Keep doing it until you get it right. Now let's talk about graphing an actual equation. Something with 3 variables, x, y, and z, all in the same equation. The way we do this is we're going to try to graph all the intercepts. To do that, we're going to first keep our x, but plug in zeros for everything else. Plug in a 0 for y, and plug in a 0 for z. What do I get? 3x equals 12, so x equals 4. Repeat the process now, but let's keep y. So plug in a 0 for x, keep y, and plug in a 0 for z. And solve. For y equals 12, so y equals 3. And lastly, let's do the z. So plug in a 0 for x, plug in a 0 for y, and keep the z. And then solve. 6z is equal to 12, z is equal to 2. Where are these points? So for the x equals 4, we write down the 4, comma. Since we plugged in a 0 for y, now we put 0, and a 0 for z, we put a 0. That's where that point is. For the y equals 3, we plugged in a 0 for x, we got a 3 for y, and we plugged in a 0 for z. And lastly, for the z equals 2, we plugged in a 0 for x, we plugged in a 0 for y, and we got a 2 for z. These 3 points are going to help us graph the actual equation. So now what you're going to do is you're going to find these spots on the axis. For x, 4, 1, 2, 3, 4, there we go. For y, positive 3, 1, 2, 3, and for z, positive 2. And what you're going to do now is you're going to connect those dots to form what will look like a triangle. And you'll be shading in because the graph is a plane. Not a line, but a plane. Let's see that one more time. So in this one, again, find the three intercepts. Keep x, 0 for y, 0 for z, and solve. 3x equals 6, x equals 2. Now 0 for x, keep your y, 0 for z, and negative y is equal to 6, so y is equal to negative 6. And then lastly, get rid of x, get rid of y, and keep your z. Negative 6z equals 6, so z equals negative 1. Now you can make the pointing if you want, but we're just going to basically put these onto our three axes. First up, our x equals positive 2, then our y equals negative 6. I'm going to have to approximate where it is. And then lastly, our z equals negative 1. That's going down. And go ahead and connect these into a triangle. And shade it in. I know I didn't do the best job of shading, but it's okay, you get the idea. This plane is the graph. I want you to think about this reasonably. Before, we were graphing lines. Lines come from equations with an x and a y. Two variables, because 2 points make a line. Now we have 3 variables, and 3 variables, 3 points, make a plane, just like in geometry. So when you're graphing in 3D, you're graphing a plane. Alright, if you have any questions, go ahead and leave a comment, and I'll see you guys in class.